So we can start. I hope this talk not give you the nap that you need after the food. I hope so. If you need it, I hope you bring your pillow and have a good nap. So today we'll talk about level up your RDBMS productivity in Go, because all the people works with database most of the times, and maybe they know that maybe are they a little painful to use because there are a lot of things you have to handle to make it correctly. For example, problems that might see during this talk. First of all, I want to introduce myself. My name is My name is Davide Imola. I'm software engineer in Red Carbon, which is a cybersecurity platform company which builds a platform that handles by artificial intelligence security incidents. And I'm also a community manager for Schrödinger, which is a community of open source developers. And we are also an event organizer, like Developer and so stuff like that. There is my colleague, Ludovico.
There is a bug here. Okay, I am Ludovico. Nice to meet you. I work in Red Carbon as well as VP of Engineering.
Okay, perfect. Perfect. So, a little disclaimer about this talk, because I think it's important before starting. All the things inside this talk are highly opinionated, and there is no standard of doing it. It's simply things that we have discovered and stuff that we have liked the most by using Go and using databases. Examples are all in PostgreSQL, but all the stuff works with other SQL databases. Okay. And of course, NoDB have been armed for the purpose of this talk. Yeah, but a couple was truncated, but I try to put a little bit near here. Okay. Okay. Let's start with the actual status, or what are you doing, or what are we doing, or what might go wrong this time. Okay. First of all, handling the DB code. Who says already this thing? I think most of Go developers already seen this, and I have a thing to say. Let's be honest, who loves writing this code? No one? Okay, perfect. Because Copilot was not a valid answer for this thing, neither ChatGPT asking them to rewrite it. It's a little pain writing this thing all over again. I don't like it. I don't like it. Other things that... Sometimes... okay, no, I think sometimes it goes down. I don't know why. Okay. So finding hidden errors in SQL. If you see this slide, you can catch the error. Yes, exactly, upsource. And of course, if you run this thing, you make, there is not a compiler error, because everything is okay. But when you run it in your production code, you may find the error, because upsource does not exist. Of course, it's a typo. Of course, we want to use the users table instead. Okay. Of course, there is another problem, which is SQL injection. SQL injection is a type of attack, a well-known type of attack, where users may perform strange queries within our database. For example, in this query, everything is fine. There is a select star from user where ID is equal 5. Is equals 5. Test. Okay. Is equals 5. Is equals 5. And of course, it's fine. It's working. And there is nothing that we can complain about it, because you are passing 5 and you're returning the user with the selected ID. But if you make this thing and pass 5 or 1 equals 1, it's still a valid query, but it has a major downside, because the query will return each rows in the table. Doesn't matter, because it's fine. We don't parse it, we don't do anything, simply because 1 equals 1 is always true. Other thing that may be annoying is code andb that may be out of sync. For example, taking the code that we see here, if you do an alter table by adding the column email, as you see here, we are adding the email column. Of course, the code is asking to scan for 2 rows for the select star. Of course, there is something wrong about this code, because when you perform this migration, Go needs to map all the 3 columns, and not only the 2 that were ID and name. So if you start running the code, this is the error, you can get it. It's, I think someone may have seen before this type of error. Another thing that might be interesting to talk about is the problem of manual type sync and possible downtimes. If you do stuff like manual migrations, connecting with your database and working about with it, there is always a problem. And the problem is always between the chair and the monitor, of course, because we are the problem. If someone thinks that he may not be the problem, it may not be the problem, sorry, not sorry, but we are all problems, because we are humans and we make mistakes. Last thing, maybe, is automated testing. Let's rewind with the error we had before, that the table upserts. Of course, we had this problem about, I'm bored to take it, okay? Okay, there is this problem about upserts. Of course, if you start automate your test and start mocking it, of course, mocking it will make you cry, because you can't see the problem itself. Because if you mock the DB query or the entire list user function, the code is no more executed directly to a database, a real database. So the problem is not catched during development. Instead, it's catched when it's going outside to production. And I think it's not a good idea to do that. So what we are covering today we are covering 3 things, 3 little things. The first is SQL-first paradigm, which is a cool thing that we are using in our company. There is migrations, and of course, test containers or Docker testing. Let's start with SQL-first. SQL-first is a very cool paradigm. Go developers like press buttons, like the penguin, and generate code, because code generation is fantastic and we don't have to do a lot of stuff. So in SQL-first, you have to simply to write your SQL query, write it down, like select star from users and stuff like that. Run a tool which generates type-safe code from your queries and schema, because it parses the schema, it parses your query, and it generates a type-safe code, which, so he understands, okay, I have a varchar, it generates a field that is a string. After this, you may enjoy writing your application by calling the generated methods and using the type-safe code that is generated by this tool. There are other approaches that you may find by working with databases that are ORM, that are object relational mapping, which is a programming technique that enables seamless interaction between object-oriented code and relational database. In simpler words, you may find something that is working like a struct. You have a struct or an interface, and you have functions like update, create, get, list, and stuff like that. I don't like it so much, this approach, but we talk about it later. And of course, there are query builders, which are tools or libraries that provide a programmatic and often fluent interface for generating DB queries. So you're writing your SQL queries mixed with a little bit of code. So why we don't like ORM in Go? We don't like it because you don't have the chance to write a SQL query and to learn it. I think it's one of the most important things. We don't like so much the app is built for Go. I don't say ORMs are not a good thing. I'd like to use another term, I can't. They're not a bad thing, but there is a problem. The API built for Go is not so easy, they are not so cool. ORMs are fine. If you are using, for example, TypeScript, there is Prisma. Prisma is wonderful. Or if you're using Java, sorry, there is Hibernate. Hibernate is cool too. But of course, the API built in for Go, I don't like it. We don't like it. And you can't use all the DB features. For example, if you're working with Postgres, there is the JSON-B field, the JSON-B type, and you can filter inside your JSON-B, for example, by searching for a type, for a specific field inside your column. Of course, you can do it with an ORM, because it's working as expected in all the databases. Why do we don't like query builders? They are not type-safe, because they are not generating code. There is a mixed approach between SQL and code that may be complex to read and understand, so it's not so easy. And of course, as it's not type-safe, you have to maintain all the types and all the mapping to have it work, and we don't like it. We have made this beautiful table. Of course, all the rows are important, but I think the most important is this one. I don't know why, but OK. But as I can say, you don't have to hate ORM or query builders, but you can use it as a fallback. SQL-first approach might be interesting, might be wonderful, but it has major outsides when it comes to complex queries. Of course, in this case, using an ORM or query builders for some specific case might work very well instead of SQL-first approach. For example, if you have a strange query that you have to build around your application, you can do it with SQL-first. OK, let's talk about migrations, and not jellyfish migration about SpongeBob. But yeah. Migrations, what are migrations? Migrations are SQL code that you have to run to perform some sort of editing to your database schema. You have an app query, an app where you put all the queries to perform for applying some changes to your database. For example, create a table, drop a column, drop the database. No, I think this is not the case, but OK. And of course, there is a down if you want to revert them. For example, you have done something wrong with your, or you have to rewind your code. You can roll back your changes and performing this now migration. Of course, the most important thing is that migration is always committed beside your code. So whenever people start using your code, simply may run a migrations up, and everything goes up, and the database is just fine as it wants to be, because sometimes it may be difficult to have it always synced. And of course, run it, because if you don't run it, it may not work. You can't run it manually, but I don't like it. You can write it in a job, cron job, Kubernetes, and stuff like that. For example, you can fetch if there is an edit, you can run it. And you can run it in your CD pipelines, but it's not recommended. And that's all. There is an evolutionary database design, which is a technique to avoid breaking DB interactions between releases, because you do releases of your database within migrations. Of course, you have to automate your test because it's important. You have to be sure that everything is tested. You have to do small migrations. You don't have to write a migrations that creates 15 tables and 200 columns. It's not fine. And of course, breaking changes must be introduced in 2 steps, because if you introduce a breaking changes, the application that currently is run in your infrastructure dies because they didn't find what they need to work out. Okay, last but not least, test containers or Docker test. Test containers are a beautiful thing. We have talked about mocks and stuff like that. But you can always, but it's better if you start working with something that is real. For example, with a database, if you do your test, you want to perform your test to a real database. This is maybe challenging. You may decide to create a Docker compose to run your infrastructure. But there is this cool thing that is called test containers, which is a tool that starts up the container you are asking during the setup phase of your testing. It keeps up the infrastructure, because it's not only Postgres. You can run whatever you want. Of course, if you run Elastic, maybe you have to wait a few minutes. And after all the tests are run through this container, the cleanup phase will destroy all the containers that are currently running in your infrastructure. This is a cool thing because you are sure that the code is tested through the real infrastructure, the real, very, very real infrastructure. Because, for example, people may say, OK, database, I test it through H2 file. OK, but H2 databases, file databases, as I measure outside, they are different from Postgres, from MySQL, from other database RDBMS management tool. So you may have your code that is working, and when you perform your publication, is not going to work. OK. As programmers, we love demos. We love seeing things broken up, like this fantastic robot. And of course, may the demo god be with us, because we don't want to be this robot. And I leave Ludovico the stage.
I used some years ago to work with robots. I was a robotician. And in my opinion, demos with robots are more fun, especially when something doesn't work well. They fall down, they blow up, not very good smell sometimes. OK, so I prepared a little project for show you the flow of how to work with all these tools that Davide has presented now. This code is not very well written. The idea is not to show you how I'm very, I don't know, let's say too complex to explain. Okay, so the idea is to explain you the flow of how to work with all this stuff. We can start from migration. We use a tool that is called dbmate. There are a lot of tools that you can use to handle migration in your code. I like dbmate because it's very simple to use. You can use it in other languages because you write only queries, so only SQL query. But it's written in Go, and so you can use it also like not only like a tool, a command line tool, but also like a library to automate in your code the migration. So this is a simple ORM project that works on just a simple a table that is called user. So what we do in our migration, this is the first migration of our project. We just created a table in the up part of the migration. Then in the down part, we have to drop the table because we have to undo all the stuff that we do in the migration. Okay, so let's start about what we want to build. That are our protobuf API. I use protobuf because I like gRPC. Not protobuf, sorry. This is what we want to build. It's just a simple service that allows you to handle users. So you can create a user, list user, delete user, and get user. And you can't update the user, but it's not important. We can then write the code to also update the user. So this is our interface, so the contract between the server and the client. And this is the definition of user in protobuf. If you don't know what is protobuf, it's like a middleware language where you can specify the contract or your application, like or OpenAPI or like I don't know, GraphQL. And then you can generate code for bootstrapping the server part, and then to write also automatically writing the client. But this is not important. What we want to say here is that we have this. We want to build this API, and then we have just we work on this structure, this user that maps our user in the database. Okay, and then we have all the API. So to create a user, we have to pass a name. To list the user, we have to pass pagination stuff, so limit and offset, etc. To delete the user, we have to pass the ID, and to get the user, we have to pass also the ID. Okay, so usually when I write the first query, I just run this command. That is dbmate up. It's a little bit complex to write code when someone is writing to you, because usually I'm very fast, but okay. So this is not required. What is doing this dbmate app is just taking my migration, apply it to a real database that is running on my computer. This is not necessary to our flow, but I usually do to check manually if all is working okay. And then we can start to write. Let's start writing SQL code because it's the main part of our talk. So we can write our queries, so the queries that we run with the database directly in SQL, as I told you. With this syntax, it's quite easy to use. It's pure, in this case, Postgres SQL with some nice stuff like you can define parameters with this @id or with this magic function, they call it, that is SQL.arg, and then the name of the parameter. This will generate the code with a parameter called ID, in this case, parameter called name, in this case, and the parameter called limit, in this case. It's quite, in my opinion, intuitive. And what you do then is you write this comment near your query that instruct sqlc, that is the tool that you use to generate the code, on how we want to generate to run this query. In this case, the name is the name of the query, so the name of the function that we will call that will be generated. And then there is a command part that is essentially what will this query return. Usually we have three main commands that are many. This query will return a lot of stuff, not only one. This query will return only one, stuff like in the case of the get. And there is also an exec, then there are some more complex features that are out of the scope of this talk. And given that, what we do is just run this. I prepare a makefile. The command is just sqlc generate. It's a little bit complex now because it's working on a bin directory, but the command is just bin sql generate. It's super fast, and what this do is create. I've already created it, some files, and I will show you them. There is a db file. This is db.go. Is always the same. Is just a boilerplate of our interface. So it's create a type, a structure that is called queries. That contains a database client. Then it creates a model file where we have a generated code for all the tables we have defined in our schema. So we have only one table, and it generates a table called the user with this stuff that are the same stuff that are inside our table here. So this type. With KD, name, create data, update data, etc. And then for each SQL query, so each SQL file, sorry, we define in the folder is looking for, it creates a generated file that implements all the query that we define in the file. So for instance, here we have a list user, and here we find I don't know why they are not in order. This is new, but here we have a list user with the args that we defined, and all the boilerplate, the Go boilerplate to run the query, handle error, and scan the stuff that it gets in our struct. This is super simple. You write the query, and then you have just this file. Now, what we want to do is we want to implement our server. So this will be fast, super easy, because we have already defined our proto definition. So the proto definition also generates a code. It's just an interface that we have to implement. And this is the implementation of the interface. I just call the create user stuff, passing the data from my database from my query, the parameters of my query. I handle errors, and then I return the response. I usually, in this case, write. This is not generated; it's written by me. This is just a function that converts from the database model to the protobuf model. Usually, you just map the types, except from some strange stuff like timestamps that are handled a little bit different between Postgres and protobuf, but it's quite simple, just a map. And then we can write our test. So, as Davide told you, our tests are written mainly using a tool that is called, to be honest, the library that we use is called Docker test. The approach is called testcontainers, but testcontainer is also a library, is a very generic project that implements this stuff in different languages, like also Go, Java, Node, etc., etc. We use in particular this library that is called Docker test. So in this case, we have to write some boilerplate. What we are doing here is just creating a Docker container. We run Postgres inside of it, and that's all. We have to wait that the project, the Postgres is running and is ready to accept the connection. And then we return just a connection string, and this is very useful, a purge function that I can call when the test is complete. This is just the definition of Postgres. I'm using Postgres 13 Alpine. We can use 15, what we want. With this username and this password, this is pure Docker here, pure Docker stuff. And once we have this boilerplate, this code, this function, we can write our test. Again, our tests, there are a little bit again of boilerplate that we create the Docker stuff. We create the pool to connect to the Docker. We instantiate here our test server where we run test again, and then finally we will create the client to run the test. And then the tests are super easy to write. In this test, for instance, I just make a request. This test only that if the database is empty, I can get it. I can get empty response. So I create a request. I run the query with the client. This is automatically generated. And then I just check that I have not error and that I have 0 result. In this test, I create a lot of user and then stuff. Then there is a test that create a user, etc., etc. How much time I have? Okay,
yeah. So
okay.
You have to be fast because I have to finish.
Yeah, I want just to show you that the running part is very, very fast. It takes 2 seconds. Really useful. What I like of this approach is that you write integration tests like they are end-to-end end-to-end tests like they are unit tests. Very simple, very useful. And that's all.
Okay. Perfect. The demo went just fine, thanks God. So let's talk about the new status now. So what might we have fixed? Well, let's talking about handling the DB code. Do you think we have already fixed it? I think so, yeah, because all the things now is being generated automatically through sqlc. Errors in SQL syntax is now handled, is not showing up, but if you run sqlc, it catches SQL errors because it performs the query and understands if it's correctly. And of course, if you start writing against a database, it catches the errors while writing it. Okay, other things, SQL injection. We have all the things that now is type safe and type consistent. So, and you don't have to format printf the query because everything is already handled to not have SQL injection. Other thing, code and DB out of sync. Okay, this thing is covered because sqlc, when you write a select star, it automatically changes the query and perform that each row is identified in the query itself. So there is no more the star. That might be the problem itself. So you are querying the exact number of columns, and the code is created on those things, and it's fixed. We like to make fixed. The problem is always between the chair and the monitor. Is fixed, yeah, because I'd like to say that fixed, because now everything is generated, handled by a machine. Of course, that might be errors, but it's. Yeah, they doesn't have to do nothing and have the computer to do stuff and correct us while we are wrong or when we are making mistakes. Automated testing is covered because, as we said, we are performing the actual queries against a real database, a real Postgres database, or a real image, a Docker image. The image that he shows in the demo is a simple image from Docker Hub. He's pulling the image from Docker Hub, but if you start digging a little bit, I think you can use also images that are in your registries. Yes, I think I finished first. Okay, last 2 slides. As I said, I'm an event organizer. If you are maybe interested, I'm the organizer of this event. It takes out in Florence. It's an international event. It goes Open Source Day. It will be 7 and 8 March 2024. The tickets are all free. You can join for free. And if you're interested about open source and stuff like that, we talk about Go, JavaScript, Rust. We have talked about different things. So if you maybe are interested, you can join us. This is our contacts. If you are maybe interested, Ludovico has LinkedIn and Twitter. I'm trying Mastodon. I don't know why, but I tried. And that's it. We have the Q&A, and please consider to give us a feedback. For example, if you have a good nap during our talk.
Thank you guys. Thank you, Davide. Thank you, Ludovico. Let's move on to the question part. So, all right, I see many questions. Okay, I'll start from here, and then I'll come there.
Hi, thanks for the talk. Very interesting.
Yep.
I have a couple of questions. No, one question regarding sqlc. Is it able to understand joins, table joins, or complex queries like CTE or recursive queries? So can generate the typed results, or is it limited to simple queries?
Yes. SQLC is a project that is evolving. What it does is it doesn't communicate like other similar projects directly with the database. It has internally, let's say, an engine that emulates, that understands better the query language. So it depends on the feature that you are using. For instance, all you mentioned is quite good to understand it, joins, etc. I work, for instance, with view and materialized view, and I've done a PR in the project some years ago to make them understand it. Sometimes, with very complex query, it complains about the type, but you can help with just casting in your query. Yeah, you overwrite it. But for example, there is the query, you made 2 points, varchar, so you say, okay, you're not understanding that it is a varchar, I'm saying it to you, this is a varchar. So it automatically translates into a string in the code.
Okay, thanks.
Thank you.
Okay, next.
Thank you guys for a very fun talk. I had a very nice nap as well.
Perfect.
A question. You mentioned that when you do make migrations that are a breaking change, you do that in a 2-stage process. I'm assuming that the first stage is just add the part without breaking it, and the second stage is the actual breaking part and cleanup. How do you currently do that? Is that a 2 merges that happen one after the other, or like how are these stages organized for the deployment in a way?
Okay, we are very fast in the deployment. And so what we do usually is not, I'm not very, how can I say it, maybe there is a way to do it better, but I didn't find it. What we do usually is make the first part of the migration, like if you want to change the name of one column, you create a new column with a new name, you copy all the values, but leave the whole column there. Then you run in production the migration. When the migration is in production, then you can write the second part that is removing the old code. In this way, when we run the migration, we don't introduce in the few seconds where the migration is run, but the old code is still running. We don't introduce. It didn't break.
Of course, I can say you can be more explicit in the second migration. For example, if you add for a little bit of time, you can, for example, recopy the things that you are sure that have been generated by the old version, and have all the things now in the new version. Of course, it's something that is useful to have the both version working, as we don't want to have downtimes in our applications.
The problem is that is a lot of manual process here. I'm looking for a way to handle it better with automation, but I didn't find a way to do it. So if you have any idea, please share with me, with us.
That was exactly my question, because I didn't know how to organize it better without the manual file.
No, I think that the only way to do this is manually. You have to be very, very careful in this. But
Okay, I'll go here first.
Thank you for the presentation. My question is, you mentioned that do not do migrations in the CD pipelines. What else would you, where, and when would you else recommend to do the migrations?
Okay, I don't like migrations in your CD pipeline, because in CD I'm talking about continuous integration and stuff like that, because you have to connect, for example, the GitHub Actions within your database and create some sort of connection between the two words, and it's not so a good practice. We work with Kubernetes. Kubernetes has this thing called jobs. There are jobs, and we use customize. And customize has a cool thing that you can say, okay, before.
You mean Flux? No?
Yeah, okay. Flux has it. Flux is a GitOps tool for Kubernetes. We're saying to GitOps, to our GitOps tool, okay, before start the application, please run this job first, and only if this job is going fine, perform the update of your code. Because so you are sure that the database is synced with your release. And this is one of the way that we do, and the way that I prefer. Of course, you can handle through the code itself. For example, dbmate has a library, and you can perform the migration within the startup of your app. I don't like it so much, this approach, but you can do it.
Yep, thank you.
No problem.
One problem with using SQL-first as your source of truth about database schemas and queries is that it's all written by hand. So you can make an error, like you can make an index on a column that doesn't exist, or you can use a foreign key on a column that doesn't exist. So how do you validate this before it actually hits the database and destroys the database?
The migration are run inside of the test. I didn't show you,
right.
But when I, in the boilerplate of the test code, there is a part that runs the migration. So I'm testing also the migration. Of course, if you are very complex data, a lot of stuff, especially in production, usually I tend to do a manual test where I download all the database or I duplicate the database, test migration first, and then I'm quite sure that all is working well. Instead, with typos and the other part, sqlc guaranteed you that the code you write in SQL is then checked against the migration.
Yeah, because
and the
if you maybe in the SQLC configuration file, this is a YAML file, you have to say what is your schema. So you're saying, okay, I'm writing the queries, and of course you have to generate code starting from the schema. And the cool thing about the tool that we use, which is dbmate for migrations, it automatically creates the schema, all the schema. So it interoperates to understand which is the actual status of the database.
Yeah, to be honest, in last year we used the schema directly in our test database. So I created the database, then applied the schema generated by dbmate, and then I tested against it. Sometimes when you make a mistake in running migration, you could have the schema that is not synced with migration. Now what we do is in our test, this part here, that runs the migration, the real migration, so all the migration folder using dbmate. This is why I like dbmate. directly on the test database. So in this way, I test the migration. Or better, I test the up part of the migration. I want also to test the down part, but we don't do it now.
Makes sense. Thanks.
Thank you.
Hello. Thank you for the talk. So I have a question about the Docker test or the test containers.
Yeah.
So I understand the importance of using services in your test environment that are as close in your local environment during testing that are close to the production environment. But I am wondering if there's any additional benefit of using Docker test instead of having your Docker compose file inside your project, defining your dependencies during your test, for example, PostgreSQL, and then running that Docker compose file instead of writing Go code for initializing this Postgres containers. So why Docker test instead of just having a Docker compose file?
I can answer. I think the most important and the cool thing is that is all handled through code. And of course, you can start up the container through your code when you do the testing phase. So you start, for example, you're doing it in your local environment, for example. And for example, maybe, I talk about myself, I usually tend to use the Docker Compose to write in tests. Of course, most of the time, I didn't remember to bring up the Docker Compose. Because, okay, maybe it happens, so this is a problem. Of course, the things that we love, that you can bring up all the things, and it bootstrap the database in a different part, so you are safe that what you are creating is always different. The problem with Docker Compose maybe are cache.
Let me,
yeah?
because I think that you was referring to different things. In my opinion, you can use both. So you can use, you can write a real integration test with Docker Compose that expose all your services, because you can communicate also with other microservices, not only the database. In my opinion, this is very opinionated for me, the database part is part of your application, is part of the code. And what I like personally of the Docker test is that you can write integration tests like they are a unit test. This is why I use integration. We use Docker test in this case. But usually I tend to use it only for database because you know, theory say that you should not put a lot of logic in your DB, but you have to. So if you want to test a query with some complex filter, you have to test it with databases. And in this approach is simple with respect of using the Docker Compose. With Docker Compose, usually what we do is span other dependencies like other microservices that in our test we mock.
Do we have any other question?
Sorry, again me. Now, regarding now Docker test, is how about concurrency? So I've seen in your test code that you are hard coding the port where
it's not hard coded. It creates a random port. You just tell him to Docker test where you want to, what port you want to expose.
Map.
Yeah, you want to map. So this is the part of the, and then it creates a random port in your system.
Okay, and this means that if I have two different files, so maybe I execute in parallel this test,
you have two
instances of the database.
Yeah, you have two instances of the database. It's very fast. Usually we have an instance of the database for each package. So user package have an instance, and then we don't have here, but if we create another package, we will have another DB.
Okay. Okay, thanks.
Are we good? Do we have any other question? All right, so thank you again, Ludovico and Davide. Thank you.